through the ML is going through a lot of inflection point, and the key reasons being essentially around all. I mean, since some things. No. Okay, yeah. Essentially, the key drivers have been the compute capacity, and that's where I come from. I've seen this grow from the Moore's law happening in the semiconductor space of how the capacity is increasing, data growth, model sophistication, all of that stuff, right? And 2022 has been a year of generative AI, from essentially impacting creativity, the productivity. Looking at, for example, some of the data we showed, our Code Whisperer, which helps the coders generate their code using comments and so on, and put prompts in the code. It's 57% sort of faster in terms of completion of their coding things, right? Gartner says there will be 7 trillion increase in global GDP over 10 years because of productivity improvements because of generative AI. So this is becoming huge, right? But what is generative AI? I mean, I'm sure you guys, from my perspective, we have seen the traditional AI, which is all about predictions, which is all about classification, computer vision problems, recognizing objects, and all of this stuff, right? That's been a classic use case we've been running. But what happened in generative AI essentially is about being able to generate content, and whether it's text or a code or images or videos, and that's the whole aspect of generative AI comes in. Now, if you ask me, the generative AI concept of when you look at the NLP aspect of things, it started with a seminal paper in 2017 called "Attention is all you need." Now that's where it actually started. But what changed in 2022, right? In 5 years, BERT models were there. People were experimenting with BERT and doing things. But what changed in 2022? And what answer in my mind is scale. And if you look at the scale, how the model sizes have been growing, it kind of reminds me of the Moore's law from semiconductor days, that it's actually Moore's law plus plus, because Moore's law was actually increasing the capacity of transistors, reducing the size by half and reducing the cost by half every year. But model sizes are growing much faster than that, right? And that's basically what happened. The model's getting bigger and a lot more bigger, right? And that's what changes the game basically. And if you look at it, the whole idea about attention is what you need. Why it was a seminal paper is because it's the first time created the most sophisticated mechanism of creating two words or sentences and paragraphs, right? Idea was to have a multi-dimensional sort of an embedding, as they call it, where you would essentially, if you look at it, how the sentences are spoken, the food is great, but the service was terrible. Every word has relationship with the words before and after it. Now that is the context, right? Now imagine when it's a food has relationship with every word appeared before and after it. Now if I'm able to capture that relationship, in some multi-dimensional way, not a single dimension of whether it's closeness or fartherness or whatever, that's one dimension, but there could be multi-dimensional sort of a relationship. If I can capture that accurately. Now, that's basically what attention mechanism gave, that you could essentially create a multi-dimensional sort of a relationship. And if I learn it over a large corpus, so two things now. One is the corpus of data where this words and sentences appeared so many times in so many different contexts, I'm able to capture the smallest nuance of every word, every sentence, and so on. And that's the whole idea about it. But how do I store that? It's the model size. So what happened in the last many years is model size have gone up. So even the people who are developing this model, the surprise of the capability of these models have been able to create, right? So that's sort of what happened in terms of when you look at, so when the two variables there, the size of the corpus, which is used for training, and the size of the model to be able to store that nuance sort of semantics of every sentence, every word coming in there. So that's what attention is what did to the industry. Now, so again, quick ones, I'll just skip through this in interest of time. This encoder-decoder architecture, I'll only focus on one thing, that there are encoder-only models, which are essentially like the BERTs and the Alberts, which basically would capture, the multidimensional embedding, as I said, multidimensional vector of the semantic interpretation of every word, and then expand that to every sentence. So these are very good for things like sentiment analysis. I say I love Delhi, so you create an embedding which creates a semantic interpretation of that, and you can get a sentiment analysis. You could find a missed sort of fill in the blank, a masked word. You can find the masked word. It is appearing in a context, so you know the context of the entire sentence. I can figure out what's the context of the word. That's a encoder-only model, which is basically. Then what you see in a chat GPT is a decoder only model. So what they do essentially is that they essentially would mean it's a one-dimensional thing that it's able to see, starting with a word, what's the probability of next word coming? What's the next word coming? So it's essentially doing a next word prediction. They're also called auto-regressive models because you don't require any labeling of data because you have the full corpus coming in, so you already know what's the next word coming in. So these models are trained, including ChatGPT, in terms of next word prediction. So you say, hey, my is the first word. What's the probability of the next word name? Probability of the next word being named is 99%. Another word is 98%, and so on and so on. So you essentially have the next word and the probability of the word appearing. You join them together and keep figuring out my name, what's the next word, and it's always doing it. That's how if you see ChatGPT will keep predicting the next word and building the entire sentences. So these are decoder only models, very good for next sentence, next word prediction, and generation of content, like the way ChatGPT does. Then, of course, there are encoder and decoder models. These are also called sequence to sequence models. These are essentially you have a sentence coming in. Where are you going, for example? Now it also does encoding into a sort of a latent space. And that encoding is used to generate, from a decoder point of view. So the encoder is the front end, decoder is the back end. So these are essentially used for translations because there will be as many number of words in a sentence coming in. They don't have to one-to-one map. Where are you going is 4 words, but you translate them to Hindi, and that's very good for translation. But some of the models like Plan T5 and some of these models which are LLMs are built on a encoder-decoder architecture. They're called sequence-to-sequence models. That's the reason prompting of LAN T5 would be different from a little different from how you prompt a GPT kind of a model, which is only decoder-only model. Okay, so again, moving forward, obviously that's the language models. Then of course there was this, you're essentially taking images and describing those images. Somebody said, can we take a text and generate those images? That's why DALL-E came. So, and then of course, one thing which I want to cover as part of this with image generation algorithms are very clearly one thing which I want to, something called variable autoencoder than GANs. I'll not go into technical details. People who are, separately, if you want, we can go more detailed discussion on that. But only one thing I want to highlight in this slide is essentially these are probabilistic models. So essentially what happens is when you're training on a set of images, when you have a set of images and you train your model like a variable autoencoder on the left side, so you essentially training process would train a probability distribution, a PDF, basically. So which means that you're seeing images and you're basically creating a latent space of probability distribution, which is sigma and mean and sigma square, right? And then what happens is you have the PDF which is trained. Then you randomly pick up a sample which is in that PDF, which fits in the probability distribution function, and you generate something which is meaningful, right? That's how most of these. So the probabilistic. One key thing I want to highlight is they are probabilistic functions. Every time you generate, a new model generated, and if it is trained well on that PDF, more meaningful things will come. If it is not trained on that PDF and the PDFs are a little bit hazy, then the match for what you get is not going to be as accurate. So that's an important element when you deal with any of these, what I call the foundation models, whether they're LLMs or whether they are image generators or so on. And I can show, in interest of time, I'll move forward, but there's a nice pictorial description which I can see how this sort of a latent space sort of gets created. Maybe we'll skip for now. This is also other process where if you see instability diffusion also works through a similar sort of a diffusion process, which means it's basically when you're training the network, you're training on a noise function basically. So you start with an image and you start destroying that image by injecting noise following a certain schedule. And then once you learn that distribution, you start with white noise and start injecting and denoising it to generate a relevant image. And that's a similar sort of a stochastic concept used in generation. Again, they're all stochastic processes, how they follow a particular denoising sort of a path, which is a noising function which is learned, and then you start injecting, denoising it from a pure noise, and overall create a reverse stochastic process to generate a relevant image which matches the text which is given. So this is an example of how it starts with pure noise and eventually something meaningful comes out as you denoise using the noising function. Now, key thing also highlight is basically, and that's the power. Basically, they're very good at few shot learning. Zero shot and few shot means that out of the box. It's been trained on certain things, and you ask him to do something like a chat GPT trained on next word prediction. That's what it's been trained on. But you can ask questions, it starts generating relevantly. So again, that's a zero-shot learning out of the box. It starts performing well on tasks which has not been trained on particularly. Now, few shot learning is that if you want to do, for example, sentiment analysis, right? I mean, you can give some examples of handful of 4 or 5 examples, and they start learning those examples, start generating more relevant output by, and they're very good zero-shot learning. This graph is important. It says that in terms of number of examples needed for large models beyond a particular set of parameters, you see how good the number of examples sort of shoot up. In terms of, so a number of examples are so less, but accuracy is pretty high when the number of parameters are very high. So large models are very good few shot learners, and that's the power. That's the reason when you prompt. That's the reason the whole idea of prompt engineering comes in. Then you're prompting it relevantly, you're able to make it perform different tasks which the model has not originally been trained on. So I'll skip this slide, the language model, these are general slides. Now, interestingly, when I mentioned that the key working with language models, there are a lot of papers which have been published that they're truly probabilistic models. And people say, oh, this has hallucinated, it gives me wrong, incorrect information with perfect confidence. Now, that's not a problem or a sort of bug in the model. That's a feature because that's exactly how they're supposed to behave. So whatever you do, they will hallucinate unless, in certain, in some cases, or they can't be guaranteed. There are other techniques available, how you make them sort of more deterministic in terms of the answers and not hallucination. But by nature, I want to highlight because they're probabilistic, they will hallucinate based upon what kind of data has been trained on. Now, this is essentially a very nice comparison. I like this slide a lot. Traditional ML models, you essentially create a labeled data, you train your models, and for every task, you train a different model, even for NLP or any other task, doesn't matter. Whether it's text generation, summarization, you essentially would have different models trained with pre-trained labeled data and models. But in foundation models, fundamentally, what has happened is that paradigm has shifted. Now, as I said, some of these are autoregressive models. ChatGPT is an autoregressive model. You don't require labeling of the data because you know what's the next word in the corpus of data which you're training on, right? So you essentially take unlabeled data, create a foundation model, a large foundation model. Of course, the cost of that is very high. The GPU compute needed is very high. But once you've done that, you can adapt it. And I'll talk a little bit more about what those adaptation techniques, right? Adapt it for different tasks, whether you do through prompting, whether you do through fine tuning, whether you do through prompt tuning, and I'll talk a little bit more about all those 3 or 4 aspects of how you do it for different tasks at hand.
Yeah,
so now this is just a slide about, go ahead, please. Go ahead.
Just wanted to bring one question which is sort of relevant to this topic. So Nitin is asking, startups don't have a lot of data, but how do they use generative AI? Do they always need to depend upon pre-trained models? So I thought of bringing that question up because that's the relevant topic.
Yeah, it's a great question. I think actually, and I'll cover a little bit more, but I'll give a quick answer and then a detailed answer. Let's discuss when we covered a few more things. The quick answer to that is yes, you're right. I mean, because all these large models are trained on large data. So out of the box, they're able to do a lot of good stuff, right? By just doing prompt engineering, as I said. I mean, it's trained on so much of data. I mean, you can do a lot of meaningful stuff by using prompt engineering. Because prompt engineering means only a handful of examples of telling it, I want to do, detect some, even I want to detect certain, sentiment in a particular sentences. I want to detect, abusive nature in a certain particular set of sentences. So you can train them. Hey, this is abusive sentence, it's not abusive sentence. This is, positive sentiment, negative sentiment. So all the stuff you can give a few examples, and it learns and starts producing without having to have any enough data and start doing something meaningful, right? That's the whole idea about, but I still feel there's the moat or the key differentiator would come from data eventually. Because what happens is, and we'll talk a little bit more about retrieval augmentation techniques, where you essentially, your data is your proprietary data. That's where you create the moat and differentiation, however little or more it might be, to bring in that data and make something more meaningful, which is more relevant to you or more relevant to your domain. And we'll talk a little bit more about that. But yes, I mean, out of the box, yes, I mean, pre-trained models can do a lot of meaningful things. But for startups, where is the moat, right? I mean, if you can do it, I can do it too, right? I mean, by using similar examples. Either I'm a super duper expert on prompt engineering, and we'll cover a little bit more about that, or I have data which I'm using to generate more relevant responses, which are creating the differentiation. So does that answer the question? Maybe I'll just
question. Yeah.
But yeah, the detailed thing we'll have a little bit more.
Yeah. Okay.
So this is just a slide on telling you there are different types of model. Text to text is what you've seen. The chat GPT is more of a text to text model, text to embeddings, which is important. And we'll talk a little bit why embeddings are important. And multimodal is you write a text, generate an image, generate a video, generate 3D animation. A lot of companies doing all of the different sort of applications in that. Okay, now why are these models successful? As I said, first of all, the transform architecture is very, 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 very pivotal in the sense that because its ability to capture, and the more I say, the less it is, ability. I mean, I've seen a lot of simulation around the last many years. I started playing with BERT in 2017 when that paper came out, and so that intuition has stayed with me. It's very powerful. The ability to capture the semantics. I actually one of the first projects I did was to write English language essay assessment using BERT and the ability for us to be able to capture the nuanced intents in terms of semantics, the coherence was outstanding. I mean that's what the whole idea about the attention mechanism and transform architecture is very, very transformational. Then, of course, we talked about in-context learning, which is zero shot. Means that out of the box they're able to do something meaningful. Few shot means give a few examples, as we talked about. So that's another powerful feature. Other things, the emergent behavior at scale. That's a very interesting one because I sort of alluded to that in the last slide. That even the people who developed ChatGPT or any of these models were surprised at the capability at scale. Because when the model scaled up, when it was able to capture those nuanced interpretation of semantics into a large sort of a parameterized sort of a model, ability for it to do things were even surprise the old developer itself. So they could be in new behaviors, in newfound sort of features, which these models start supporting and surprising even the developers at scale when you start doing it at scale. Now, I also want to add over here that the size of the model is a function of how much data you have to train. Now, if you've scrapped the entire corpus of English language data and there's not a very much major additional data available, no point in increasing the size. If you're able to capture, unless there is enough data to capture the additional nuance, you don't need to. If the nuances of that semantic interpretations across the corpus you train on is captured well in the current set of parameters, you don't really. There's no value increase in size of the model, for just for doing it, right? So again, if there's enough more data coming in and there is another corpus, 2x corpus coming up, of course you'll increase the model size and you'll see the emergent behavior would be you could some new interesting capabilities come out of the model. Now, this is just about RLHF. Essentially, it's a very interesting thing because you've seen ChatGPT hallucinates, so you've seen some interesting answers which gave you, and you were like shocked. What is it saying? So every model LLMs today have what is called the reinforcement learning based on human feedback. So which means that one is of course the unsupervised learning, which already happened, as I said, the auto-regressive thing. Now this is supervised fine tuning because every time you respond, it picks that response up and sort of takes it back into it and do a fine tuning based upon the reinforcement. I'm calling it reinforcement learning because the feedback from humans, this is good, this is correct, even that's factored in and reinforced. Wrong answers are picked up and be able to sort of understand and learn from it. That's the reason it improves the performance over time. Right? So I'll just, these are just three examples of, three types of prompts. As I said, one is simple prompt, which is zero shot, which you all, I'm sure, have been using with ChatGPT and other equivalent, LLMs. Other aspect is basically few shot, where you give a few examples and it starts learning by examples. And third important thing is there are two processes. One is the role based. So if you say I'm a financial analyst, or I'm a doctor. So you essentially puts that role and responds more appropriately based upon the role. That's also a pretty powerful mechanism of doing that. So you can prompt it that way. The other element is also prompt chaining, which means you could essentially give a stepwise sort of a chain thing. Do this, then do this, then do this. You split the task into a chain and you give a chain prompt, you can do it more meaningfully. And I'll show an example of that as well. So here is an example of, I think all of you, I've already covered that. But here is you say, here is a tweet, negative, positive, neutral, and then you ask, okay, I'll give you now a tweet, tell me what the sentiment is, in gender sentiment. Now, this is an interesting one, the chain of thought prompting, right? Now, initially, if you don't give any such chain or a stepwise sort of instructions, it says a juggler can juggle 16 balls, half the balls are golf balls, half the golf balls are blue, how many golf balls are there? If you do it, if it has not done reinforcement learning, it'll answer, invariably it's given wrong answer. But now if you give them a little bit of a more stepwise sort of a chained event, right? That have step one, there are four balls. Step two is there are two golf balls. Step three, there are one golf ball, one red golf ball. So there is one red golf ball. So explaining what to do, now it starts behaving and giving the right answer going forward. So that's another way of the chain of thought prompting, how it's done, right? Okay, now come to the little bit more deeper into in terms of people keep using these terms, model fine tuning, model prompt tuning. What is model fine tuning or what is prompt tuning, right? So there are two different things actually. So model fine tuning is you essentially pick up a pre-trained model, whether it's Chat GPT, that also allows you to fine tune, or whether a Flan T5 or any of the Llama models or whatever. Right? You pick up a pre-trained model. Now you essentially create a task. You have a task to be performed. You say, hey, here is my task. Here is the description of the task. Here is output I want from the task, right? That when I do task A1, this would happen. Task A2 would happen. You have a data. You essentially use that data to train that model and generate a new model. So it will be a pre-trained model A. It has been modified. The weights have been modified, and the new model comes out, right? Similarly, for task B, you create a different model B because when trained on task B, task C, you create a different model. That's how you do, fine tuning of a model, right? However, prompt tuning is a little different. Prompt tuning essentially means that you're taking these three tasks. Prompt means you have tasks in the prompt, and you have what needs to be done in the prompt. You take the task prompts with multiple parameters, and you essentially generate more relevant prompts to and without changing the pre-trained model. Pre-trained model weights stay fixed. So you do not train the pre-trained model. You essentially build a model on top of it or on the sides of it, which learns how to prompt it more relevantly based upon the prompts which are given in or data which is given in, so that appropriate response comes out. So you're essentially doing a prompt tuning. So it's much lightweighted compared to a full-blown, not even full-blown, doing a model itself to be fine tuned based upon the additional data which you have. It's much lightweight, much cheaper to do that, right? And if you look at it, what are the approaches of fine tuning? The one is feature based fine tuning, and it means that you have a label training set, you have pre-trained LLM, but you essentially keep it fixed. The model, the pre-trained LLM is fixed, but you add additional classifier of sorts or something and update and train that classifier based upon the label training set. So this is again lightweight because you're not disturbing a large model and changing their weights and training that model. You get that? You're essentially creating, my task is to do some classification. If that's the task, you put up a classifier layer or a classifier sort of on top of the pre-trained model, and you essentially train it along with the fixed LLM. But you basically train your classifier. When I say update, that means you're training it and updating the weights of the classifier to perform it based upon the labeled training data set which you have. That's a feature-based approach. The other approach for fine tuning is about you essentially only update the final layers. That means you create the final layer of you add additional layer or something, but the rest of the model doesn't change. But the final layer of the model you essentially update to do some specific task based upon the labeled training data set. Now that's a little bit more expensive than the classical, but again, it is much lesser because you're keeping the rest of the model pretty much fixed. Third is basically where you say, I basically would update the entire model, entire LLM based upon the label training data set, right? That's expensive because that means that all the millions and millions of parameters are updated in a your data set may be much smaller than what it's been originally trained on. Doesn't matter, but you'll have to go through the entire sort of iteration of training and loss function computation for the entire large model and update entire set of weights, entire weight vectors for the entire model. That's expensive. But then that gives probably the best results in terms of the accuracy, whereas the other other approaches give a little lesser thing, but it's much cheaper, much faster, and so on. So that's sort of the trade-off you have to make when you're fine-tuning the models. So all three approaches are used based upon where your use cases are, how big is your data set, what is the cost to train it fully if you have to fully modify it, because that's where you got the maximum accuracy. But if you have, plus what the tasks you want to train it on, right? The set of tasks are much larger. If you're only doing a classification in the end, it's much cheaper to do a classification layer and only train that model to do that. Right? So that's essentially the fine-tuning approaches. Prompt tuning is where I was telling you. That's very interesting. That's where the whole idea was that you essentially train the model to react or to appropriately work on respond to a particular different types of prompts or tasks which come in a prompt. For example, if I ask, it's not been trained, it doesn't do well on how to bake a cake. Now, what happens is that to get an appropriate response to that particular prompt, and it's a very simple prompt application, prompts can be much more complicated than that. So I use basically train what I call a lighter prompt tune model, which essentially will generate a more appropriate prompt for the LLM to generate the right response. So LLM weights are fixed, frozen. LLM weights do not change. So it's a much lightweight, it's a higher quality result. Just if you keep fiddling manually with the prompting thing, it's manual effort first of all, and and you still don't know what results you're going to get. So what happens is in this model, you essentially train the embeddings. Whatever embeddings go to LLM, those are trained to generate the appropriate response. So that's much more higher quality in terms of the response you get from the prompts you're training it on, right? And so again, much and again, other aspect is if to consider is that if you go to create some specific response from an LLM by using prompt design, you go to be limited by the size of prompt you can give because every model has a limitation to the input it can take at the input sequence. So in that context, and plus the cost, you charge on tokens. So how many tokens are you giving in input? How many tokens you're generating in output? You're charged by that, right? So those aspects are taken care of because you can optimally design the prompt size. You can have optimal size prompt going in, but response is pretty much much more accurate than what you need, right? So it's very important. Fine tuning, prompt tuning has become probably the de facto approach these days of how you tune pre-trained models for your own use case and tasks, right? So that's the
Anurag,
prompt tuning. Any questions on that?
interject. Anurag, just to interject.
Yeah.
Couple of questions on infra are coming in. I think infra you will cover as you in
Yes,
the
I'll
follow-up.
maybe if that's the more focus, I'll jump on that very quickly. I'll skip some of these things. If there's more questions are coming around, that yeah, of course, infra I'll cover a lot.
No, so just to give you infra, there are a bunch of questions. Then there are a couple of questions on the use cases in different industries, software development,
Okay.
financial services. Um, Jacob says also just want to bring in a question here. Recent enhancements with GPT-4 using plugins like Wolfram uh, have greatly reduced the hallucinations have greatly reduced using these plugins. There are use cases for both zero shot and custom data few shot. We have developed products with LLM with both. So just a comment, I think, Jacob, from you. Please
Okay.
feel free to
No,
add if
I can take that. Okay. Okay. No, good. This is so. Let me move forward. That means people are jumping ahead, so I'll also jump faster. I'll not stay on this one. Okay. So this is prompt tuning. So any questions around this tuning, prompt tuning, and this? Okay. So I want to highlight one more thing that there's. I'm sure you guys are aware of the Stanford alpaca experiment, right? I mean, that essentially used a technique called self-instruct to generate the instructions to fine tune a pre-trained model, right? And resulting model performed actually at par with a bigger model. So this much smaller model, 7 billion parameter model, and the self-instruct generations were done using ChatGPT. In this case the Da Vinci 003, and it's much bigger model, but the performance was pretty much close to the bigger model. So again, this technique of using a smaller pre-trained model like a 7 billion, 13 billion parameter model, but more effectively fine-tune using self-instruct sort of a mechanism, which Alpaca gave, using another LLM, right? Whether it's a big or small, doesn't matter. You do a good, training data from and use self-instruct to train the prompt tuning for this. The performance of these things, the smaller model also really goes significantly up. And we've seen this is becoming a very popular recipe now for prompt training because a lot of our customers also doing the same thing. Then instead of using large model and cost incurred the large model, they are using smaller models, using a very thoughtful mechanism of using their own data and using mechanisms to generate the self-instruct based, fine-tuning of prompts. That and invariably they're seeing excellent results on that. That's something which is in my mind because of the open source nature of some of these models, because these weights have been given to in open source, a pre-trained model. It allows a lot of startups. Somebody asked this question about the startups with less data and less propensity to spend on training a few, because a single run of a chat GPT kind of model on a training run could take $3 to $7 million, right? Or of GPU, GPU sort of a compute time, right? But if you can do much smaller, sort of a compute by using these techniques and get a great result, so that sort of an ROI is pretty impressive. So this has become a standard recipe. Many of our customers are following it, using a smaller open source slash, pre-trained models and using these techniques to prompt tune it using self-instruct or mechanisms similar to that. Then there is also a very interesting technique called LoRa, which is, I'm sure many of you are aware. Basically, it's low rank adaptation. This is basically equivalent to if you've been AI/ML practitioner, you would have used PCA, principal component analysis, the whole single value decomposition. Using similar eigenvalue eigenvectors, you essentially pick up where much smaller. So you freeze the rest of the weights, so pick up much smaller weights. In this case, A and B, which is much smaller, sort of a superset a set of the overall weights. You freeze just the weights, only decompose it into a principal components, and you essentially and you're able to get a reduction in terms of your computation in terms of the number of weights you compute by an order of sometimes 10,000 times, and GPU memory goes down by 3x. So, and again, with very minimal loss of accuracy. It's very similar if you use the PCA aspect of it. Mathematically, it's similar, but of course, the whole flow is going to be different because in terms of how you sort of implement that. And there are a lot of open source implementations available for example, even for Llama and Alpaca, there are LoRa-based training implementations available, fine-tuning implementations available, and you can check it for yourself. The amount of that with minimal loss of accuracy, your compute requirements go significantly down. So now you combine this, the open source models of Llamas of the world, pre-trained models, you combine that with self-insert kind of a mechanism Alpaca gave, you combine them with LoRa. Oh, that's a very, very interesting sort of an ecosystem which is emerging now. I'll pause here. Any reaction to this? Okay, so let me move forward. So now that brings me to the fact that yes, of course, when you say plugins are coming in ChatGPT and other places, but essentially the only mechanism, the best mechanism or more foolproof mechanism to not only minimize or reduce or eliminate hallucinations, and also bring traceability to what basis the LLM is making answers on, is called retrieval augmentation. So essentially, what if I remind you, there are two aspects of LLMs which are very critical, which are very value in terms of one aspect is the embeddings, because as I said, using attention mechanism, the multidimensional embeddings powerfully capture the semantics. That's one part. Other part is the generation aspect that is able to fit a probability distribution and generate something meaningful, more human-like. Right? We'll use both things over here, but not in a single flow. So we essentially have customer data. So you want to say I am a healthcare person, I have a hospital, I have a huge amount of patient data which I've gathered. So I want to basically make sure all the corpus of any LLM which answers on is based on this data. I use embeddings, which is using an LLM, whether it's a ChatGPT or the high dimensional embeddings, the better accuracies in terms of semantics. You take these embeddings and show it into some sort of vector database. Vector database allow you to do a similarity search, like a cosine similarity or a dot product similarity. Now, query comes in, you essentially embed that query also and do a semantic search into the vector database using this cosine similarity. Now, that data corpus, portion of the corpus comes out, which is relevant, more relevant to the user's query. Use that create augmented prompt and ask LLM, hey, please find the answer to this query in this particular augmented data which I'm providing you. And you could create a lot of metadata to be able to trace it back. When LLM answers anything, you also know what is this set of matches which had come from vector database, and you can even point back that here is a document or here is a clause in the document which is being used by the LLM to answer the query. So you not only minimize, and you can even ask LLM, if it doesn't find the answer in the corpus I'm providing you or the context I'm providing you, please say, I do not know, and do not sort of answer on your own, in which case the chances are you might hallucinate. So you can even tell them, hey, if you don't find it in the corpus, say, I do not know. So you essentially have a minimized hallucination. And so these plugins are now coming in, through a lot of these LangChain frameworks. I'll talk a little bit about that. So a lot of these plugins are available, and you can build this whole thing, corpus up, and I'll talk a little bit more about that. Here is the reference architecture from AWS perspective. So we essentially are saying that we have a semantic sort of a search engine called Kendra. It has been in existence for a long time. It's one of the very popular enterprise semantic search engines over here. So we essentially would create a corpus feature into Kendra from documents, and it has a lot of connectors built in. From an S3 buckets, you could shift in a lot of financial data, or other data, and even scrape the web. So the web scraper is available connected to Kendra. You get that into Kendra data ecosystem, and Kendra provides a LangChain sort of a retriever. LangChain I'll talk about a little bit ahead. And within there, now what happens is retrieval augmentation can essentially do a query into the thing, get the nearest match, and let LLM use that relevant sort of a query from Kendra or corpus of Kendra and answer based on that. That's a very major reference architecture in here. Now, other aspect is basically in fact, a lot of these LLMs itself are now incorporating what's called MRKL, which is similar to what I mentioned, that creating a framework, because MRKL stands for, because one of the key problems with LLMs is essentially they're not good at uh, they will hallucinate, and they have issues in terms of memory, in terms of creating a memory, and they're not good at math, they're not good at some of this logistics. And when an intent comes in from the user query, it may not be it may not all be serviced by an LLM. It may require some computation. It may require a lot of other, things to real-time data, to be pulled in from weather or somebody else or whatever, right? So MRKL sort of builds it. That doesn't, and LLMs are not reason, right? They're essentially probabilistically generate something, right? So you require more reasoning sort of for interventions there. So again, this is where this whole MRKL architecture comes in, where you essentially say you have a language model, and from there you have an input adapter, which could feed in data from multiple sources, whether it's a calendar, calculator, additional experts, or databases, vector search, all of that stuff, or wiki APIs or whatever, right? And then you basically augment all that data together and use another language model, the same language model again, to now use it as a generator, using the data and generate. It's more of a retrieval augmentation sort of a thing. But the idea is that you can have multiple agents, multiple experts bringing which feed to that. That's where LangChain comes in as well, right? Because LangChain essentially does something similar, like an MRKL sort of a thing, right? Where you essentially could not only have a lot of have multiple models it's an encapsulator, multiple prompt templates, multiple tools available, whether it's calculators or whatever, multiple vector databases, all the retrievers available. Now you could create agents and conversational chains in terms of how you could sort of I would call it a semantic kernel. It's like a semantic kernel where user's query is interpreted, broken the intent into multiple intents, and each intent sort of is served into different models and different tools to get the responses. Now the responses are chained together to generate the final response to the user, again through another LLM. So this allows that whole orchestration piece, and that's where the whole open source architecture is moving, where a lot of the implementations are working that way. So when I say plugin, so even AWS has plugins into LangChain now. For example, when I showed Kendra has a plugin into LangChain. So you essentially from a LangChain thing, you could sort of go and query into Kendra in terms of give me the nearest matches to this thing, or it can data from S3 or other or wherever databases or whatever. So all those plugins are getting available. The plugins are getting added by the day. So this is becoming a very very important sort of a platform which is getting supported very very actively by AWS as well. And again, when you say models can be abstracted into SageMaker endpoints. So you could directly within model invoke the SageMaker endpoints to really get the models out there and so on. So let me quickly do a quick demo if it's okay. Let's see. Look at it's an interesting one. I'll just do a healthcare demo. Can you see my screen? Aish, can you see my screen?
Yes, I can. By the way, Jacob, feel free to sort of discuss, or it doesn't have to be a question. I see Jacob says, Anurag, that we have developed a support chatbot based on our documentation with RAG, retrieval augmented generation. LangChain is super
Cool.
cool. We have used RAG to develop the chatbot.
Excellent. So this is just an example I'm showing you, just a quick demo. This is essentially using, intelligent document processing of the medical documents. See the summarization happening. So you see this whole insurance report coming in. This is using, AI21 LLM, and you could do a Q&A as well. And you can do the summary, the first page, huge page summarization happening, right? And this is using, AI21's, model on SageMaker. This hosting on SageMaker, as we're doing, it's live right now. You could essentially do a Q&A here. For example, I can ask a question. What is the patient's chief complaint? I just ask the question, here's the answer. The patient's chief complaint is this, whatever. You could do this, what is the notable points in patient medical and social history? The second question I ask the chatbot starts answering the question. He has history of pain. Again, this is coming again similar retrieval augmentation flow where this entire patient data set is loaded into the backend or LLM or whatever, and then of course using AI21 LLM to generate these responses. So this is a quick. Since you guys have done some of that, so you'll be very familiar. But it's very powerful. The whole, and this is right now in production, I believe, at one of the customers. But this is just a sample demo. Let me go back the slide. So other RAG demo is similar, but this is running on my local machine. So this is essentially what I've done is being a semiconductor guy, I've looked at semiconductor data sheets, right? For example, you have from a TI data sheets like these, and very difficult for designers to look at every feature of these microcontrollers, right? I mean, what's the frequency, what's the ARM architecture or processor architecture and everything. So I've sifted these PDFs into the corpus. I'm using in this case, a Pinecone database, and this is like pretty raw code. I can now run it on, for example, this is what I'm doing. I'm asking a question. Let me ask a query, for example, a simple query first. That what is the? Can you see my screen, guys?
Yes.
So let me ask a question, which ARM core architecture is using Citara? Now I'm using Flan T5 here as model, as a LLM. So if I ask a raw Flan T5 without retrieval augmentation, the answer I got was x86, which is actually super duperly hallucination, because ARM and x86 are very, if you guys know, right? So now I'm just running it now here. So this is now doing as looking into the Pinecone database and getting the relevant sort of basically embeds this particular query, sends it to the Pinecone database, gets the relevant response from the vector database, and runs and asks the language model, which is Flan T5 here, or Flan T5 large model, to generate the response. So it'll take a few seconds because right now vector database is online. So just don't bother about there are some warnings over here. And this moves ahead. If you can see the screen, and here's the answer for you. Fairly accurate, and it even gives you the frequency in which this particular processors are Cortex A53 is running on. So this is an example of using retrieval augmentation, how you could get accuracy. I'm not publishing it, but you can even point to which data sheet and which page in the data sheet this particular answer is coming from. Make sense? Okay, let's quickly move ahead.
Anurag, just again interjecting on the topic of accuracy. Nitin Agarwal asks that generative AI is predictive in nature. I want to know how this can be used in industries where accuracy is super important, like financial services.
Yeah, absolutely. So this is exactly what I was saying. Yeah, it's a brilliant question, because if you're building a sort of a Q&A or any generative sort of a generation sort of a capability, our RAG flow is the sort of the best bet you have to go. Otherwise, you can never be sure of, because probabilistic in nature. However much you have trained the data on your own corpus, fine-tune the data, the model on your corpus, you still can't guarantee that it will not hallucinate, right? And that accuracy, and for you in financial services or even in healthcare, your responses have to be 100% accurate, unless it is basically a human in the middle sort of a use case, or whether you're just summarizing an addition. If you have a paragraph, you're only summarizing the paragraph. Those aspects are fine. But when it has to go a little bit more open-ended Q&A, you just can't do it open-ended in the sense that it will hallucinate, unless it's a use case where there is a user sitting there and he's trained that once in a while the guy will give a wrong answer. Please validate every answer you're giving, and even give it feedback. RLHF, as we call it, right? Reinforcement learning with human feedback, or give a feedback back to the LLM to sort of learn and not make the mistake again, that sort of thing, right? But unless the other use cases would have to go through something called a RAG or an equivalent of that, where you essentially have not just the accuracy of your answers, but also traceability back to where the answer is being picked up from. You use the capability of models, as I said, LLMs, the accuracy of the whole process much higher, because you're using two capabilities which are paramount for LLMs. One is the embedding, the complexity of the embeddings, using that, and using generative capability from a limited corpus. You're limiting the corpus, bringing in traceability, and using the ability for LLMs to be able to generate human-like good response, even a guided response in terms of how you want to structure the response. So you can even prompt it to structure the response in a particular way. So that's both the power you're using and still being able to do that. But you can't let it open-endedly, it will hallucinate. That's sort of my answer. And that's what I've been advising everybody to look at. So this is a very interesting one. I'm just playing a video instead of running it over. So it's image analysis. So what you've done is use recognition, which is AWS's service on a computer vision service, being able to sort of recognize and create attributes from images. So this is an image which I'm loading. That image is of a centrifugal pump, right? So it's using Amazon recognition to detect the image, to basically label the image, basically, and what is the image and create some attributes to the image. So here you go. The images have been labeled now. So every aspect is centrifugal working pump and what every aspect of centrifugal plug. And parallelly, these attributes have been ingested into a LLM, and it does a 200-page line summary of what the image was. So it's giving an image analysis sort of a use case. And you can now start asking questions around that image. Hey, what insights would you like? So he'll ask a question. What is the purpose of the centrifugal pump? And then it gives you an answer. It's using Anthropic's Claude V1 models for LLM to be able to do the summarization or a description or even Q&A generation out of that. That's sort of another use case which is as a demo we thought I'll showcase. Okay. So next we come to now, let's move on to what are the original questions were coming in terms of the sizing and model selection. So model selections are important because any model you select has an impact on the training costs, whether you're fine tuning or even if you're not fully tuned at training yourself, you're fine tuning. It has an impact on the cost. Also has an impact on inferencing, not just the training cost, but even on the inferencing cost. Because inferencing cost, if it is a big model, you would require about GPU which can have the X amount of memory. If it's a large model, you just can't do without that, right? So again, having that, it's very important to make sure that you have that upfront in terms of what you're picking the right model for a use case. And some of the factors you evaluate LLMs, these essentially, obviously, you need to have authenticity, speed, and latency, grammar and readability responses, cost important, unbiased. The biases are important. Biases are very, very dangerous. Based upon what data has been given. How can you backtrack? As I said, the whole idea about backtracking back to where the response comes from, safety, responsibility, some of these things. Now, interestingly, there are a lot of evaluation frameworks available. So I'll not go through each one of them. It's a bunch of things I've captured. If you look at any paper which comes out of a new model which generates, they will give you a reference against some of these benchmarks, some or more of these benchmarks, right? So there again, generalization abilities on grammar, paraphrasing, the different elements are captured. NLP, natural language understanding, reasoning. There are stuff around, if you look at it, robustness and general coherence of explanations, right? There are things around, F1 score about accuracy in terms of the response you're giving. There are things around, even mathematical sort of reasoning abilities, mathematical abilities, common sense reasoning abilities around, things around, even coding, Python coding tasks. So there are various of these available, which you can, when you're fine tuning it and seeing the base model versus fine tuned model, you can run some of these things. We've seen on some of the tasks have we improved the accuracy of these scores or not. So moving on to the GenAI ecosystem. So in terms of what we are seeing, we categorize into 4 categories. One is the model providers. Now, these are the Anthropics and AI21s and Amazon, AWSs, and OpenAIs who are building their own foundation model, who are spending that millions of dollars to build their foundation model from scratch. And then there are model tuners who essentially are doing stuff. We're picking up whether open source or proprietary models, but they're fine tuning it, either they're instruction fine tuning it, or they're tuning the entire model based upon, for the use cases and so on. So they're the model tuners. And then the model consumers. Model consumers are not doing a very heavy lifting on AI ML or generative AI. They have use cases. They're exploiting the existing fine tune as well as by default, original models to be able to build some use cases for them. So we are seeing in India a lot of people around model tuners and consumers, providers. Not yet, maybe a handful, specifically in video and image generation and audio generation space, where they're building their own model from scratch, the GAN style GANs, and building on top of it, sometimes stability and stuff like that. But some of them have some proprietary models as well. Now, some of them are moving from their proprietary models onto using AI using stability diffusions and so on, right? But that's what we see. Then, not to forget the infrastructure providers. Now, there are 2 aspects. One is, of course, infrastructure like AWS and other people who are able to provide you the underlying hardware, the GPUs and custom silicon or accelerators for you to do cost effectively train and inferencing models, right? But also software infrastructure, companies who are essentially optimizing the model, like OctoMLs and so on, or libraries which are able to you take a model, optimize it because optimizing model means reducing your inferencing costs significantly, right? So those are then, of course, the prompt tunings. We saw the open source LangChain and all that stuff. All of that stuff falls under the software infrastructure providers. Let's now switch over to the use cases. I think, and every day the slide is growing, right? And that's where I can pause and I can open some Q&A right here on this case. So from the text, from a note-taking, summarization, to copywriting, from marketing perspective, to sales, email, lead generation, to support chatbot. That's obviously obvious one, the Q&A piece, right? Where everybody wants to enable the customers through chatbots on a very sophisticated, open, relatively more open-ended Q&A than what dialogue flows had originally in the last many years have enabled, right? But those are very limited sort of dialogue flows which is possible, but now more open-ended Q&A is possible, especially on your own corpus. General writing, writer block, right? When writers start writing, they're blocked, right? But you get something from a generative AI, you have jumpstart, right? You may not use it as it is, you may change it, but the productivity gains are immense when you do that. Smart enterprise search, which is semantic search. Code generation, huge aspects of it. We have our Amazon Code Whisperer, and as I said, customers across the board have found like a huge improvement in productivity of generating code, because you write a code, you essentially write a code, it generates the next set of code. You write a comment, it suggests you what code should be and stuff like that. So your ability, I can even do a quick demo or a video I can run where I didn't have a single line of code. I only read one comment, and it's based upon that comment, it started suggesting what my next code should be and next function should be, and so on and so on. So that's the obvious one, and then of course
So now on that,
one interesting. Yeah.
on that, there's a question from Shoaib Khan. What are your thoughts around software development and how it will change at a fundamental level with Gen AI? Shoaib,
It is
feel free
already
to.
changing, Shoaib. It is already changing. You yourself would see, that the in fact, it was my conversing with my son yesterday, who was a software developer at Cadence, and he mentioned that I use ChatGPT to generate a code which otherwise I would have, and the company is banned, by the way. I mean, Cadence has banned the usage of ChatGPT directly because it's sort of security issue in terms of what these guys do is they will go right on their own on phone, do a run ChatGPT. Oh, I want to do this conversion here. That generates a code. You cut paste that code somehow, get it back to the Cadence system and sort of do that. Not a good thing to do, but most people are doing that. Sooner than later, some security aspects would be covered up and whatever. So it'll be mainstream. The Code Warrior, the Code Whisperer, for example, has support multiple IDs in a very safe way. You don't have to go to a third party thing and write something over there. It's right integrated in your IDE, and essentially it basically works through an IDE environment and very nicely sort of integrated the Code Whisperer, which allows you to generate that code. So so absolutely, you have to upskill. My point is, software developers have to upskill. The below average programmers will have to sort of think and upskill themselves, because it'll be the algorithmic nature and more complicated system architecture level. That's where it will upscale. But rudimentary code would continue to get generated, and your productivity has to be sort of looked at. That you're generating productivity gains would have to be factored in as software development becomes mainstream. The generative AI in coding becomes mainstream, right? And more than just the code, I mean, it's all about also about security. And one thing which mesmerized me was about the security audit. I mean, you give a code, they'll give you immense, such in-depth analysis of your security, violations which your code is making, and security vulnerabilities in your code. Right, so that's immense. Even despite you do so many other things, do so many audits, things which didn't get caught into audit. Now, Code Whisperer and other tools are able to do that and suggest to you in terms of from a security point of view. Other aspect is legacy code. And how many of us work on legacy code? Startups may not, but people who work in enterprises, we have worked largely on legacy code, maintaining that, right? Now, your ability to write uncommented code and say generate some business logic around that, and generate comments around what the code is doing. Immense productivity improvement in managing legacy code, right? So you see test case generation, automating your test case generation. So I think the coding is one area which will immensely change using generative AI, right? Of course, then images is another aspect, design, art generation, the entire whole transformation, right? I mean, you see one of our customers when, even when I remember, this, I think one of those used cars companies created a big sort of a studio, spending crores or a couple of crores of rupees, where they could come in, get the car on the pedestal, car moves across, and 360-degree camera angles will click, backgrounds can change. Now, this invested crores and crores of rupees doing that. So every car has to come there physically, get clicked, and then get uploaded in the image, right? Now we change that. One of our customers are changing that significantly, right? Why? You click an image in a Chandni Chowk with the dogs barking behind and stuff like that. You send it over, and it automatically kind of sort of changes everything, changes the background, enhances the images, and do that. I'm pitching the pitches over here, but look at the transformational abilities of what is happening, right? Whole somebody mentioned about questions around gaming, right? All the avatar generation, 3D generation, right? I'm entering a company out of Stanford these days with part of a generative AI accelerator, right? Those guys are they're able to generate full 3D animation movies out of just prompts. You say, I want somebody to be rotating or dancing or doing this move. It immediately generates an avatar doing that move. From an actual video to a 3D animation, right? So one of the demos they gave was this. What is it called? The movie, the Natu Natu, that song, that Oscar-winning song. They played that song and they was able to capture every nuance of that move and created a 3D animation on an avatar mimicking that move. That's how transformational this whole thing about in the gaming, in the movie, in the animation industry. This is going to get impacted. That's sort of happening in that space, right? Then of course personalization. If you talk about the whole idea about video personalization, right? If you've seen the My Cadbury's My Ad, right, with Shah Rukh Khan campaign, where he recorded it once, right? But now they allowed every different local sort of businesses to say, I want him to say my company's name at that particular sort of a juncture in the video, that okay, is Diwali aap isi jagah se maal kharid diya or whatever, right? And he advertises the local sort of a store there, right? And I mean, I think millions of those local stores who otherwise could never afford, never even imagine, dream, had a personal ad coming in, and that ad can be uploaded on their WhatsApp channels and everything to their own personal community. Hey, Shah Rukh Khan is advertising my small sort of a shop nearby and stuff like that. So it's very transformational. And the use cases are coming and coming and coming, but it's been transformational what generative AI is doing to this whole creative world as well, right? Another use case which is very very close to my heart is healthcare. I did a seminar last month in Bangalore with healthcare startups, CXOs, and amount of healthcare use cases emerging are immense. Starting from the low hanging things about your report summarizations and medical report history summarizations, which you just saw a little bit, right? And also about some of these report, insurance sort of compliance generation. Those are obvious ones, smaller, low-hanging fruits, one report generation aspect, right? But interesting ones could be, the stuff around drug research, right? It's one of the favorite use cases. Now, any guesses how much a single drug, takes today to develop? Takes about $2.5 billion. 10 to 12 years. Now, the key thing is you create a set of probable candidates or molecular structure of candidates to the drugs and research through the entire process of keep iterating. Now, if I can, through generative AI, reduce and get more accurate sort of candidates to start with, it can reduce the drug sort of a discovery process by up to 20% or maybe 30% sometimes. So that's a huge. So that's another one. The protein research, all that stuff is very very important use cases.
Sorry, interjecting you. Just a quick time check. We have little less than 20 minutes, 18
Yeah, I'm going
minutes.
to finish now.
And
I'm going to
we,
switch over to the.
I want you to cover a couple of aspects on infra side. Just
Yeah,
reading
that's
out
what I'm coming to. That's the immediate
yeah,
one.
okay.
That's the immediate one. I'm getting in there. So
And
this is the
AWS,
AWS stack.
Amazon's offerings in Gen
Yeah,
AI,
yeah, that's
Amazon's offerings
I'm
in Gen
switching
AI.
over. I'm right there. I'm right on time on there. So this is the traditional AI ML stack in AWS. If you look at it right from the bottom of the largest sort of a selection of GPUs and CPUs at the bottom, they're on to the SageMaker, which essentially is basically one of the most sophisticated, orchestration environments for machine learning workloads. And a lot of our generative AI services are offered through SageMaker. And now Bedrock, the new offerings which is coming in, and there are AI services on top. So we look at the Poly, which is the speech services, the text services, all the services are on the topmost layer, right? That's sort of been the stack. And in terms of Gen AI stack, for model providers, you start basically with what I'm calling it a SageMaker. SageMaker obviously is the underlying environment, but on top of that, what you're offering is a SageMaker Jumpstart, and I'll talk a little bit more about it. This is through Jumpstart, we're offering access to multiple LLM models and as well as image models and so on, stability models, Hugging Face models, and a lot of proprietary models being offered to Jumpstart. And in a very sort of a simple mechanism of having a notebook there, you could sort of within a push button, you could essentially deploy these models at scale on your instances. New offering is now announced, which is our own LLM called the Titan LLM. We'll have both text thing, which is basically summarization, text generation, all the typical aspects which you're used to with the other LLMs in the industry, but also Titan embeddings, which is embedding model for you to do RAG and other things. Right? That's a new announcement. It's not generally available right now. It's limitedly available right now, but over the next couple of months, as sort of a beta versions are available, in the next 1 or 2 months, it'll be made generally available to everybody. That's the offering on the model provider side. On the tuner side, we again through our SageMaker Jumpstart, we are offering a lot of capability on tuning. SageMaker has a lot of libraries. When you're tuning or training, it basically has things like distributed training. You could essentially do a data parallel, model parallel, ability to you to sort of optimize data parallel, model parallel. You have multimodal, deployments available, which means that a single GPU instance, you could have multiple models deployed. So all of those aspects are part of SageMaker, which allow you to optimally schedule and optimally sort of orchestrate your machine learning training as well as deploy and inferencing loads. Then from model consumer point of view, we have just announced called Bedrock. Bedrock is our API service on top of models. Now, it'll obviously offer multiple models, not just the Titan LLM, but other models also, which are already available through Jumpstart, whether it's Cohere, AI21, or Anthropic model, which are proprietary ones, or a lot of Hugging Face, open source models, the Flan T5s and all, and Blooms and all that stuff. The hundreds of models through SageMaker Jumpstart getting available within Jumpstart, where you could deploy it on your own instances, or the same models can be invoked through a Bedrock API. So this is an API service. The fundamental thing which you're doing in Bedrock is essentially making sure that when the data gets sent on APIs, it actually resides on your private cloud, VPC, rather than getting into so your data is secure. We essentially guarantee your data to be secure. You can find these models, and the fine-tuned models would deploy on your VPC. So all data would be going to your VPC and will be secure. That's the value proposition on Bedrock. And of course, the Code Whisperer I've been talking about it is again a new announcement, which is essentially our coding companion, code generation, security sort of analysis, and all of the stuff which is improving the software developer productivity. Now, not to forget the infrastructure piece, right? We have the widest range of compute instances, right? Not just from NVIDIA's entire range of GPUs, from T4s to A10s to A100s and so on, but also specialist compute like Intel's Gaudi, which is from Habana Labs, which is a very specialist neural accelerator, is also part of the Gaudi, is also part of that that's the wide suite of availability. But more importantly, we just announced our own. It's been there, but we recently announced Trainium 1 and Inferentia 2. So Trainium 1 is our own custom chip, which basically is used for training and large models, LLMs, and stability and other language diffusion models. And Inferentia 2 is used for inference in these large models, whether they are LLMs or they are image or video-based models. So and again, the key thing is about for the same compute, you get a 40% improvement on your pricing. In terms, you can reduce your pricing, your cost by 40%, for the same level of sort of flops available for you to do on your training nodes. It has that's sort of the AI stack which we have. So options to use from an AI models, you can use Jumpstart Playground to play around. Here you can there is a playground. You can go in there, pick up a model, you can prompt it and see how it's responding it. So that's when you want to try it out. Then you can use a SageMaker hosting by actually, hosting it, hosting it on your own instance. And it's again, all these playbooks are available. You go there in the SageMaker Jumpstart page. You pick up the model you want to go. You can play around on a playground or how the model is performing, and then you sort of deploy it an endpoint there, and so on. Right? And you can fine tune it. Some of these models have a fine tuning notebook available, which you can quickly push your data on S3 and use the same sort of a notebook to be able to fine tune the model as well, right? And of course, publicly available models are from, Hugging Face. They're all available through Jumpstart. Here is a list of models which are available on Jumpstart. As the publicly available are, from stability to AI. So all the stability models are available. Alexa is our own teacher model, which is used by Alexa for so many years, is matured over so many years of being used at Alexa. Then Hugging Face models from Flan T5 to Distill GPT, GPT-2, Bloom variants, 3 variants of Bloom. They're all available publicly used through SageMaker Jumpstart. Then for proprietary models that require a little bit of a licensing from a Cohere slash Icon slash AI21 and now Anthropic as well. So you could essentially find get licensing from there, and all the models can be immediately available and deployed over Jumpstart. Now, so basically the SageMaker Jumpstart is basically, as I said, it's a machine learning hub, and you can browse through 400 plus built-in algorithms and stuff. It's a pretty comprehensive sort of orchestration sort of mechanism framework at AWS.
Anurag,
So again,
one
picking the
question
right
on
instance.
infra side, just one question. It's by Utkarsh. If a team is interested in fine-tuning their own LLM and it's a continuous process in the long term, then is it worth to spend a ton of money and set up your own NVIDIA stack, or relying on AWS training infra from a cost perspective? What makes more sense?
No, so I would obviously recommend that we are essentially very sensitive on costs which customers are facing. We've always been very sensitive to that. So that's the reason we invested heavily into Annapurna Lab, which is doing these Inferentia and Trainium chips for us, and that allows us to keep the costs very, very competitive, right? So essentially, combination thereof, essentially, supporting the needs for. We're very sensitive to. Overall, it's just that see, training is one. You're not going to train every day, right? I mean, the whole idea about cloud has been that you're not going to train every day. You're going to train, or fine tune it once in a month, once in 2 months, whatever it is. Right? You're not going to train 24/7 and 365 days a year. So in that context, you should pay for whatever you're using to sort of train those models, right? And that's the reason having your own infrastructure, in my mind, may not be the best of ideas. Maybe initially, when you're heavily experimenting, but then once in a study, I've never seen to be cost effective to do your own data on GPUs to train it. Maybe when you're doing small experiments, it's fine. But when with LLMs, the experiments are not going to be small anymore. Experiments are much bigger. So in that context, using using a cloud mechanism to do that is, in my mind, the right thing to do. And at AWS, we're very sensitive. As I said, we are having special sort of POCs which we are sort of aggressively trying to work with the customers to say, if you're going to train on Trainium or Inferentia, we're going to go all out to support you on that, right? So if you're going to do that, we're really happy to work on Inferentia based inferencing and Trainium based training also. There's very special sort of offers around that as well. So I'm happy to talk about that.
Also in the same topic, Anurag, question by Anubhav. For training large models, in-house versus AWS infra versus others. So I think you sort of covered it already, right? For deploying large models to handle concurrent requests with low latencies. So again, the cost of, please suggest some cost-effective solutions.
So it's that's the foremost thing here for anybody like you or startups who want to deploy that. That's the foremost important. Let's say if you're talking only about inferencing, for training, I think people have used the distributed SageMaker libraries to really get a huge improvement on the training costs, because you could do model parallelism, data parallelism, and all of this stuff. Now, once you've trained, you want to now talk about the inferencing costs. Now, starting with inferencing costs, what instances do you use, right sizing of instances, and so on. What's the latency? And what the real latency needs you have? Can we be compromise little latency? Those are aspects which you have to answer. And then, of course, there are so many techniques available in terms of when you deploy, you could essentially deploy multimodal, as in multiple. If you have multiple models, you don't have to deploy different instances. You could define a single instance. So we support that, right? In the sense that your costs, because you're not going to be inferencing multiple models at the same time. So in that context, that whole balancing of how many models you run on a single sort of container, that's a call you can make to really, and that's help us thoughtfully optimize a lot of those inferencing costs. Then of course we are very happy and very aggressive. Next slide actually talks about it, that if you're using Inferentia 2, it actually is for the same price, for the same performance, it's reducing the inferencing cost by 40%. compared to a G4DN or one of those NVIDIA process GPUs, right? So very happy to sort of support on that as well. So multiple ways we should look at offline. Let's discuss that. And we have special, specialist SAs who are essentially specializing only in helping our customers optimize the costs of inferencing, right? But I do look at Inferentia for sure, because Inferentia is very, 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 very pivotal for us as well. Okay, so this is
Also,
how
one quick
some
question,
suggestions
Anurag.
around the. Go ahead.
Sorry, I'm just
Yeah.
trying to make sure we address all the questions. I think I
Yes,
addressed
please,
some of
please.
the questions on the chat window, and I think the only question that I see is this deck available for sharing post the session?
Some of it. Yes, I'll moderate it and send it. I'll maybe
Okay.
moderate a few slides I can allow take out, but this I can share. Yes.
Okay, so that answers Joy your question. Yeah, Anurag, back to you. I think we've covered
So
almost all
this is
questions.
some
Yeah.
of our, as I said, wide variety of, past instances from a G4DN to a P3 to P3DN to P4D. P4D is the NVIDIA, 8 processor, 800 sort of a thing, which is the latest one, right? So across the board, and again, based upon your needs, whichever, as you say, if you're looking at a smaller model, right? I mean, you would essentially, the advantage of using a smaller model, which is instruction fine-tuned better, would be much better in terms of your inferencing costs and so on, right? So again, I'll just skip this slide. This is more like just a reinforcement that our mechanism, the way we deploy on SageMaker using container, we're essentially offering a very escrowed sort of a security in terms of your model provider's IP is very well protected there. Built-in algorithms, a lot of them built-in models. There's a huge variety of them available there in the model. And then again, why AWS for generative AI is flexibility. I'm just sort of, we covered that. And secure customization, very important. I mentioned to you that even when you're building, even on Bedrock, when you're fine-tuning your model, that model actually gets deployed on your personal VPC, and you're protected in terms of it's very secure customization. Your data doesn't leave the VPC when you're fine-tuning your model. You're fine-tuning it with security, and that's very important. The reliability of our network, the security, I mean, it's way above anybody else in terms of what we offer, right? And then, of course, Bedrock I talked about. This is the API, and which is, again, as I said, the models can be from anywhere. It could be open source models, the AI21, Anthropic, Stability, our own Titan models, all are available. The same API, just change the model name and everything works as is. And the variety of models available are pretty huge. You can privately customize using your own data, which is going to be secure, right? So we need to talk about that. And again, wide range of foundation models are supported. Tighten our own embeddings, and this has benefited from 20 years of Amazon machine learning experience, because with Amazon Alexa teacher model, and that's the basis of where the Titan model data is coming from. So very rich data which has come in for training these models. Both embeddings as well as text data is available, text aspects available. These are three of our core partners, and AI21, Anthropic, Stability. Their models are also available from foundation models are also available through Jumpstart as well as Bedrock. So this is again customizing your model, fine-tuning your model. It's pretty straightforward. This is where I was talking about our own silicon. And again, look at Inferentia 2 is offering up to 40% better price performance than a comparable EC2 instance or GPU instance, right? So we do encourage you to look at that. Premium one, similarly, up to 50% saving on your training costs for the same compute, right? Code Whisperer, if there is time, I can do a demo, but this is again, we talked enough about that. I'll just quickly move ahead. But if there's interest, I can quickly play a video. So again, generative AI is creating exciting set of opportunities, and we expect more than 30% new drugs and materials to be systematically discovered in generative AI techniques. So that's sort of major. And then by 2030, a major blockbuster film will be released with 90% of content generated from there and many more, right? But of course, as with anything else, there is a lot of policy issues which need to be addressed, from deep fakes to the toxic content. Deep fakes we're doing a lot of from a content moderation. The whole idea about content moderation is an important element. We do believe in strongly believe in a responsible use of AI. So when we talk about anything we do, we'll have a hugely sophisticated content moderation in place. But of course, there are other aspects which you have to be protected about, and we should be addressed. So that's it from the point of view of the presentation. I'll open for questions. There are, I think, several few more minutes left, and we can.
There's one question by Shoaib for the embeddings. Are they going to be multimodal? For example, text plus image, uh, the paradigm being similar to Gina.ai.
It's a great question. Right now, they're textual text embeddings, but yes, future roadmap we may actually answer. But right now, the you refer to Titan embedding, I believe. But Titan is right now the textual embeddings for now.
Folks, any last questions? Happy to take any questions. We made sure that we covered all questions in the chat window.
Is there any? There's a
And
lot of questions. I'm just going through it. I'm sorry.
yeah,
I shall we covered all the questions in that?
I mean, some of them are comments. Like, I mean, if folks want to discuss anything, we are happy to stay back. I think Anurag and I don't have, we kept even more of our time. But to best of my understanding, I mean, like Utkarsh commented something, he's built something, uh, so that's not a question per se, that's a comment. So try to cover all
Okay,
the
there's a
questions, yes.
question. What are the thoughts on token limits? How that
Oh, my
might
bad.
limit
Okay.
the size of problem we work on? Yeah, yeah. So that's a good question. One, you're talking about rate. You're not talking about rate limit. You're talking about the input size restriction, right? I mean, right? Yeah, that obviously would be limited by the model's capability. But increasingly, newer models are essentially allowing
Anurag, you lost
making
your
it
screen share.
immaterial because
You can stop your screen share.
they can. Oh, okay. So screen share is happening. Sorry about that. Okay. So they essentially can, for example, FLAN T5, it is a, oops, okay. It's basically, even if the token size is, 512, right? Even if it gets chained through, if you say 512, so it's increasingly stop mattering as you go along, right? But yeah, I mean, but there will always be limit. I think but yeah, I mean, the new models like FLAN T5, it doesn't really matter. If you saw my example, where I actually gave an augmented context of over 2,000 tokens, and limit was 512, but was able to sort of handle it. It gave me a warning that hey, you're exceeding 512. But since it is a sort of a chained sort of a thing, it really didn't matter as much from the response point of view, right? So yeah, so from that point of view, you can manage from a problem sizing point of view, you can manage. But yes, the rate limit when you go into an API version of it, rate limits are a different ballgame altogether. Right now, rate limits are happening because of the non-availability of GPUs. Because semiconductor supply chain is still, and I can tell you because I spent 2 decades in the semiconductor industry. So semiconductor supply chain is still constrained. So we essentially feel that for a while the rate limit and stuff would continue to sort of bother. But yeah, I mean, as the GPU availability becomes higher, it will be much more easier after that. What impact do you see on maintaining context when looking at larger limits of the input side? So I didn't get the question thing. Impact of maintaining context.
Sorry, I'll unmute
So
and
yeah, I think. Go ahead. Please go ahead. Mike, can you open the mic,
yeah, can
Kunal?
I go ahead? Yeah, hello, am I audible?
Yeah, please go ahead, Kunal.
Yeah, the question was more on, say, pertaining to the previous question on the token limits. Do you input as well as output, right? Do you see issues with context for the model, as in the response that it keeps giving
Yeah,
out?
yeah. So I think that's where more people are using the whole the LangChain sort of a framework where you essentially have a memory element where you could essentially create a much bigger context in hand, right? And that's where the whole idea is. You're not going to use today. Nobody is using direct you know access to LLM. They're essentially using through LangChain, or LangChain kind of a framework, where you are essentially maintaining that whole context in a much larger sort of a memory context that you're maintaining on the conversation. Lot of personalization aspects coming in, and that's how you sort of. A lot of people are even doing, okay, I maintain the context to manage the limits of the size of the input. I can take that context, summarize that context using another LLM, and put the summary as augmented sort of a data into the LLM to generate something. So a lot of those techniques, a lot of those interesting permutations, combinations are possible, especially when when we move to frameworks like LangChain. You can maintain a much longer memory, as infinite amount of memory you can maintain from a contextual point of view, and you can still manage your sort of input limits by creating a summarizations of it, and very interesting things can happen when you're sitting in the LangChain framework. But yeah, per se, if you're saying that so you have more control on the context you maintaining, right, and the limit of that history you can maintain if you're in a LangChain sort of a framework.
Got it. Thanks a lot for taking that up.
Great. I think this was very helpful, Anurag and Ayush. Can't thank you enough for taking out the time to do this. And for all Axel portfolio companies, I know a lot of you are already on AWS. But yeah, let's figure out what else we can do. Like there's so much offering available from AWS, especially for ML, to accelerate the process. If there are any questions, then Ayush has kindly agreed to help you through the process because there's a lot going on right now. And how have other companies done it, or uh, what are some of the obvious mistakes to avoid before your dev team is going at and just like asking for a budget for a specific fine tuning or something? If you want inputs on that, then both Anurag and Ayush will be helpful to do that. So yeah, thank you so much, and we'll be doing more sessions like this, where we'll of course
Great.
verticalize the topics and go deeper into certain topics.
Yeah, very happy to go
And
deeper into any specific topics. My thought was that this was a very general sort of a thing. I kept it at a little high level because the audience was mixed.
yeah,
But if any CTOs or whatever want to go deeper dive into any, I'm very happy to do that. I'm very happy to go really deep dive into one topic and nail it down. Right, very happy to do that whenever as you guys feel it's important.
absolutely. Great, thank you so much.
Thank you, guys.
Anything else, Ayush or Anurag, while before ending?
No, I think
No, thanks for the
we loved it as
opportunity.
much as yeah, we love the opportunity to doing this. I think all of you would be having my email ID as a part of, as you registered. So please feel free to reach out to me, and then I'll loop in Anurag and others. I think my email ID is there in the as you sign up. Right. So yep, that's it. That's it. Have a
Cool.
great rest of the day and the weekend ahead.
All right, thank you, guys. Thank you so much.
Bye. Bye, everyone.